Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. Okay, so first definitely try it on your own, try this problem on your own and then only continue watching the video. I think this problem is quite a doable one. So let's see the problem and try to understand that first. And we have the problem of vowel spell checker. So given a word list, we are given a list of strings. We want to implement a spell checker that converts a query word to a correct word. Okay, so for a given query word you will be given, so basically you will be given two list of strings. Okay, so first will contain the word list, which is the actual words, and the second will be the list of queries whose spellings you need to correct. Okay, and there can be some categories of mistakes. It is there written. Okay, so capitalization: if a query matches a word with the word list, case insensitive, then the query word is returned with the same case as the case in word list. Okay, we will see an example later. So I just understand the problem first. Okay, so if after replacing the vowels of the query word, any vowel individually, it matches a vowel in the word list, then the query word is written as the same case as the match in the word list. And in addition to the spell checker, it has this operator of precedence. Okay, it has this precedence. What does it mean is that when the query word exactly matches with a word in the word list, then you can simply return that. Otherwise you should check for the word up to capitalization. So you should check for capitalization error first, and then you should go for vowel errors. And if you do not get matching word even after vowel errors, then you can just return an empty string. Okay, that is what is told in the question, and you need, for every query there will be one particular answer, so you will need to return a vector of strings. So if you are confused, let's try to understand this example, then it will be very clear. So this example, you can see you have this 4 strings word length and you have these many queries. Okay, so at first what you do, you take this kite, you take the first thing. Okay, output is that first it is this. So you see that the first query has an exact matching word in the word list. This kite and this kite exactly matches, so you can simply return this word kite. Okay, I hope that is clear. Now if you go to see the second query, it has a capitalized K. Okay, so it does not match any of the letters. You can see capitalized K and ITE, it does not match any of the letters in the word list. So you try to see that without case sensitive, without being case sensitive, which is the first word with the word list with which this matches. Okay, so without being case sensitive, you see KITE, KIT, both are KIT. Okay, it matches with this. Without being case sensitive, it matches to this capital K, small I, capital T, small e. So what should be your answer? Your answer should always be an element from the word list only, so you can return this particular answer. So you can see similarly that KIT, this exactly matches with this, and hence you can return this. Okay, and similarly HARE, if you ask for HARE, you can see it is also exactly matching, so you can return that again. You say capital HARE, all are capital, so it is not matching with anyone. But if you get rid of these caps, okay, if you convert all to small, and while comparing also you convert all to small, this is the first string in the word list which matches this. Okay, this is the first string in the word list which exactly matches this, without considering the capital letters, or without being case sensitive. Then this is the first word which matches, so you return this. You see HEAR does not match it after doing anything. HEAR, these things does not match anywhere. Okay, but KETI, if you try to see this KETI, you see it does not match directly. It does not match even after being capitalized, or even after considering case insensitive cases, it still does not match. But you see, you can make it match by replacing the vowels. Okay, so you can look to replace one vowel with any other vowel. Okay, so if you replace this E by I and you replace this I by E, instead of KETI, what do you get? You get KITE, right, if you replace the vowels. So so now if you see, after replacing this you get KIT, and the first in case insensitive, not case sensitive word which matches with this is KIT. this first word, okay, K, capital K I, capital T small e. So you can just return that for KT also. You see K double E T, it is not matching with anything, and even after replacing the vowels, you will not be able to match with anything. So that will be return an empty string. And same for KETO, you can understand that these E and O both are vowels. You can replace both of them to form a letter which is kite, and you can just match the first element of that, okay, and return the answer. I hope the question is at least very clear to you. What do you need to do now? Okay, I hope question should be very clear. So now if you have understood the question, go ahead and try it on your own. I guess you will be able to solve it. The constraints are not that bad, but it might cause a TL if you try to do the extreme brute force method. So why? Because you see there is 7 for this also. So why I am telling you, if you try to do the brute force, what will be the thing? Okay, you can see that first you will try to go through all the queries. Okay, you can go through all the queries. You take the first element. Whenever you take the first element, you every time will iterate through this word list. Okay, you will iterate through this word list and check that if any same character matches, okay, if any same word matches, and then you will go for this capitalization error. You will convert maybe all of the letters to small cases and then check if it is matching. And for the vowel also you will do it, and then I mean, if you do an extreme brute force, that might cause an I mean time complexity issue. Okay, so for the extreme brute force solution, as you can understand that for what will you do, you will go to for q in all queries. Okay, so you will go through all the queries. For each query you will go through all of this word list. Okay, for each query you will go through all of this word list, and you see not only once, you will go through 3 times. Okay, because maybe for the first time you are checking for equal words. Okay, you are checking for equal words, and then for the second times you are checking for after doing the capitalization error, and for the second time maybe you are doing the vowel, okay, the vowel error, and then you are checking. But you might be thinking that this is, if this is 5000 and this is 5000, why will it cause a TLE? See, it might not cause a TLE, but you see this is 5000, 5000, and this is 5000, and when you are trying to check for capitalization issues, you need to, let's say, convert a, let's say you have a word TAKE, you I mean to check, to match this with some word like this, you need to convert each and every of this word, let's say, to lowercase. Okay, and to each and every of this word also to a lowercase, and then you can compare. But while converting this, you see you will waste another 7, another 7 time complexity. You see word dot length is 7, so you will end up in wasting another 7. So it is possible that for the worst time complexity it will be something like 5000 multiplied by 5000 plus this 10,000. For this 10,000 you might be able to multiply with 7 every time. So the worst case time complexity, you see, might exceeds through something like 1 is 7, which is the upper cap often. Okay, which is often considered as the upper cap. Okay, so that's why you need to, this is the reason why exactly you need to start searching for a better solution instead of the brute force method. Okay, so the thing which best comes to mind initially is using a map. Okay, so what can you do? What can you do is that you can use maps for all the 3 types of errors. Okay, so first of all, you tell me, how will you check the vowel issue? How will you check the vowel issue? So I hope you can easily understand the cases where you need to exactly match the letter, where you need to match the capitalized letter, that you can convert into all into lowercase and then compare. But what about the vowel? How will you represent the vowel? So let's say this is keto. How will you match with kite? So let's say you have this keto. How will you match with kite? So by an eye observation, you can easily understand that these are the 2 vowels here, and I am allowed to replace a vowel with a vowel only. So what you can do, you can replace this E by I and you will get KITO. Then again you can replace this O by E and you will get KIT. But how exactly will you do that? How exactly will you match with this kite? So for that vowel, what you can do is very simple, is that you can replace all the vowels with a common character, let's say star. So instead of replacing every time you see, whenever you see a vowel, see any vowel you can replace by any vowel, right? So whenever you see a vowel, you check that if it is a vowel, I will replace it by a star, then K, then again star. You see, you get this particular string. What if you convert this also? You, whenever you see a vowel, you change this to star. Whenever you see a vowel, you change an E to star. So you see these two strings are now identical. These two strings are now identical. You must also remember to, before converting to this vowel star method, you must also convert all to lowercase. Okay, that's definitely required for being identical. Then you can see, you can match them, these two. Okay, you can match these two for being identical. So what you can do, what can be a possible approach for this is that using maps. So how can maps help us in this question? So you see, we can use three maps because we have three possibilities. Okay, we have three possibilities. One is exact match. Okay, so you can use something like map of string comma integer. Okay, what will this do? It will take, let's say the map is same, and it will just see that whether in the word list. So for every word in the word list, you can just do, let's say W is a word of the word list, you can just do this. You initialize that to 1, it shows that this word is present in my word list. Okay, so in this way you can just check, and whenever you are processing the queries, you can just go and check whether your particular query queue, okay, whether your particular query queue is present in this same map. If it is present, it means that it is there in the word list, and you can just return the same thing. So for queries, you do not require to go through again that word list, the whole word list. Okay, that's what I am trying to say. That's why we are trying to use the map. Okay, so you have this case, you have solved it. Now for the next case, what you can do is that you can create another map. Now you see, what can be this map? This map has to be string comma string. So what will be this first string? This first string, so first of all, I will call this map as lower representation. Let's say lower replaced. So what will this do? Let's say we have a kite, something like this. It will convert everything to lowercase, and it will store something in this manner. This first string will be this, and this will be the original string. Because you see, you need to return the original string, right? In the example which you saw here, if you see that, consider this case KITE. Okay, consider this case. Okay, for this query, if you try to see, you need to return the original string in your answer. You need to return the original string, so you must not lose the information of your original string, so that you can use as a value here. Okay, so you can represent it by a key comma value, where your lowercase character is the key and your original case is the value. Okay, so you can, when you are going again for this also, whenever you are going through all the queries, let's say you are going through all the queries, let's say you did not get any same match, and if you did not get any same match, you can go to the lower representation, you can go to this map. Okay, you can convert this query also to lower, and then see that that particular lower, let's say that lower of q, if that particular lower has some element, okay, if it has some elements in this map, then you can just take this original value and return it. Okay, you again do not need to for each query. So my try is that for each query, I do not want to go through the word list again and again, and we will end up in reducing our time complexity by a lot. Okay, and we also will get accepted in that way. So you see, you can add a third map. Okay, what will this map do? Again, it will take string comma string, but it will have a vowel representation. I already told you how we will do the vowel representation. Okay, so let's say we have a vowel representation. Let's say, what do I want to do here is that if you have a kite, you need to convert this to something like this, star. Okay, and this will be your first character. Let's say this will be your key and this will be your value. Okay, so this will be your original, character, which is nothing but this. So I hope the things are very clear to you, and yeah, so that's all. You need to just create three maps. Why did you need map? Once again, why did you need map? Because for every query, you can just check for the key. If it is present in the map, you can directly tell that it was present in the word list also. You do not need to check the word list again and again, so you can hash the values. So that's why we use the maps, and I hope the approach is very clear to you right now, and I think you should be able to code it on your own. So from this point, if you are able to code it on your own, then definitely write me in the comment section that yeah, I understood your approach of this using these three maps and I was able to write this on my own. So yeah, let's see, let's continue with the solution anyways. So we have this string comma integer, let's say. Okay, so what will we name this map? We'll name this map same. Okay, again another map we have, we will name this as lower replaced. Okay, lower representation. And another map we have, we will name this as, let's say, vowel replaced. Okay, we will have this named as vowel replaced. So yeah, we do have. And now what you can do, for every, you can just go through all the string in the word list. Okay, you can go through all the string in the word list, and you can just put them into your same value and stuffs like that. So what you need to do, same string, so you just tell that this element is having in the word list. Okay, so you use same map for that. And to check for the lower, you need to convert all the characters to lower, right? So let's you consider another string lower, which you copy is to the original string, and you write a function, let's say convert to lower. Okay, you write a function convert to lower, which will take this lower, we will take the address of this lower and convert all the elements to the lower one. Okay, so I hope this is clear too. And you just check that if this lower representation map does not have this lowered already, so if map dot count lowered, okay, if this is not already present in the map, we need to check whether it is not already present in the map, then we need to just have this in our map. So let's say lower representation of this lowered, I will replace it by string. Okay, key comma value pair, I am storing in the key comma value pair when my value is the string and my key is the lowered, so that I can just quickly search it out. Again now comes the case for the vowel. So vowel replaced, I am just representing by VOW. Okay, now for vowel replaced, we definitely need the uh, lowered word first. Okay, right, we need the lowered word, and with the lower word we will replace the vowels. Okay, so let's say I will have a function replace vowels. So that will take this vowel address of this vowel string and replace all the vowels, and we will do the, you see, we are going to do the exact same thing. So yeah, I can do now is that I can just count whether this vowel is present in this vowel representation map. Okay, vowel replaced map. So I can just replace the vowel replace map, okay, by the original string. Always I will use the original string to replace it, because I will need it in my answer, I need it in my answer. Okay, so yeah, so I have it. So I hope you do understand. I did create a 3 map value. Now all I can do is have this vector of string, which is my answer. Okay, which is my answer. Now what I will do is very simple. I will go through all the queries at first, right? It's as simple as that. So let's say for auto QR, I go through all the queries one by one. Each query is a string, right? Each query is a string at first. So now what you can do, you can have these same things again. Okay, you definitely need to convert to lower, and you also need to convert to vowel also. So you just take these two values. Okay, it's the same thing you need to do while before comparing also. So I hope you do understand why I am doing the performing the same thing again. So let's say for the capitalization case, let's say one of the character is something like KITE and another character is something like KITE. How will you these both are equal, right? With the capitalization error, these both are equal. So how will you do this? You need to convert this to lower and this also to lower. If you convert one to lower, it will not be the case, then you can't compare. Okay, so both of them we need to convert. So that's why I am converting in the, while storing in the map also I am converting, and when I am going through the queries I am trying to match the queries then also at first I always make sure that I compare them. Okay, so convert them. So I did convert for the lower as well as the vowel case, for both it is true, and now one by one cases I just go on checking. So if same of query, if you get the same exact query, okay, if that you get it, so what you can do is that you do answer dot push back this exact same query. Okay, so what else, if you did not get an exact match, you can look for the capitalization error now. So for the capitalization error, so what can you do is that you go through the lower representation map of lowered, okay, and you see if this, let's say you just count the values, you just count that whether any lowered value is there already. Okay, if it is there, if it is greater than 0, what you can do, you can just do answer dot push back. Okay, so you can simply do an answer dot push back of what you see the original string was in the value of the map, so you go to the value of the map, lower representation of lowered, and just push back that particular thing only. Okay, and you see you can just do the same thing again for vowel representation also. So you see if you have vowel represent, okay, so I wrote wrong spelling for many of the vowel representation cases, so just correct it. So yeah, if vowel representation of this vowel, if it already exists in the map, okay, then only you can push back your original vowel representation. Okay, so you can just push back your original string, that's what I would do. And otherwise, if even after vowel representation or capitalization issues nothing is matched, you can just push back an empty string. Okay, you can just push back an empty string in your answer, and at the end you can definitely return answer. Okay, so is that all? But wait, this is not all. You need to represent implement these two functions, right? So I guess these functions are really simple. I guess this is not at all difficult. So what convert to lower will do, convert to lower, so it will take a string. Okay, so it will take a string, let's say str, and it will just convert to lower of all each and every character. So what I can do is that I can iterate through all the elements of the string, right? So the whole length of the string I will iterate through, and I will just do replace each and every character by to lower of that character. So there is a function in C++ to lower. So there is no function in C++ that will convert a whole it will take a whole string and convert all and each and every of them of the characters to lowercase. So you need to use a loop and convert it one by one, because there is a function to lower which converts a small character to lower character. Okay, converts an upper character to lower character on anything, but there is no such function that will take the whole string and convert it directly. So you need to write this function on your own. So yeah, so you have it, to lower of str of I. So I hope this is very clear to you what I am trying to do. Yeah, so another function I can write is replace vowels. So replace vowels. So what I need to do is that I need to get a string here also, and for this also the loop will be the same, not exactly the same, but definitely this fashion only. What I need to do is that let's say I have a char C. Okay, I have a char C which is str of I, and I will check that if this character is equal to a. Okay, and a, e, I, o, u, I will take all the cases, right? Only the smaller things I need to check, because I hope you know, because I am already using the lowercase characters. So you see all of these characters in the string is nothing but lowercase, because every time this replace vowel, what does it get? It gets a lowered value, it gives a lowered case value. Okay, okay, so I hope you do understand that. And so yeah, if I will check that if it is any of the vowel a, e, I, o, u, so there are only 5 vowels in English alphabet. So you get if there is any of the vowel, you can replace that str of I with a star. Okay, you can replace this str of I with a star. This I am doing in order to match it. So yeah, that's all for this function. Also, let's try to see if it works or we did commit some error in between. Let's try to run and see. Okay, I am using some undeclared identifier in line number 30. So let's check out that error. Okay, so this is not a string. Okay, this is a query QR. Okay, I hope you do get it. Yeah, you do get it, right? So we have it. Let's try to run it now and check. You see, we get the accepted thing for these two test cases. Let's try to run for all of them and check first. You see, we have the accepted thing. The time complexity may not be that great. You can try to convert this to unordered map. Okay, and then check if any time complexity improves or not. But I hope the approach is very clear to you and you do understand why this is not a very bad time complexity also, because I am not using a double for loop anywhere. Okay, so yeah, you see we get a decent runtime complexity now, 64% bits it is. Yeah, so that's all, I guess that's all for this problem. I will meet you in the next video. I hope you did understand the question. This was mostly an implementation based question. Okay, there was less to think actually and more to implement on this question. So yeah, that's all for this video, and I hope you have a great weekend ahead. Thank you so much.